Welcome to Kitchen Designers Forum. My name is Donald Cooper. Today's lesson is a field measure for the angled and circular wall. It is important you arrive on a field measure with all the needed tools to complete the task in one site visit. Let us review what you should have in your field measure kit. A ruler and/or templates, camera, clipboard, mechanical pencils and pen, notepad, painter's tape, flashlight, two carpenter's 90-degree angles, checklist, or preferably the NKBA Construction Details Form BMF6, level, and two tape measures. Choose your tape for line clarity and endurance. Avoid using an easy read tape measure. An easy read tape measure will not give you confidence, and you may not always have it with you. If you are new to the industry or feel apprehensive about measuring, you might want to read my article on reading the tape measure. You can find this on the website below. Occasionally, you will come across an angled or circular floor plan. You should be able to measure them without concern. In this lesson, we will be applying math formulas to a field measure. We will also be using a table of trigonomic ratios. Do not let that scare you. This lesson will be covered one step at a time. If needed, the table of trigonomic ratios can be copied from the website. The first wall in this lesson is the acute angled wall, or a wall with an angle under 90 degrees. In addition, we will be covering two different methods. Use the first method for large angled rooms with clear passage. Use the second method when obstacles are in the way. Start as you would for any field measure. Draw the shape of the room, measure what you see, and note your dimensions. Lines must be ruler drawn, and wording needs to be legible. You do not need to be scaling anything at this point. However, the shape should be in perspective to the room size. Always use double lines to represent walls. Your measurement sketch needs to be a representation of the room's present state. Now that we have our dimensions, we want to find the radius of our angle. In order to do that, we need to convert part of our room's dimensions into an imaginary triangle. Slide your tape along an imaginary straight line opposite the side of the angle you want to identify and lock your tape measure in place. Use your second tape and measure from the radius to the imaginary line and note your dimensions. The sides of this triangle have very distinctive names: hypotenuse, adjacent, and opposite. The hypotenuse is the longest side that does not connect to the 90-degree angle. The adjacent side touches the radius that we want to identify, and the side remaining is the opposite. Three formulas help us determine the angle's radius. Sin is the opposite divided by the hypotenuse. Cosine is the adjacent divided by the hypotenuse, and tangent is the opposite divided by the adjacent. Next, we calculate our formulas and round up to the nearest 10,000th. We compare our results to the angles on the table of trigonomic ratios. We can determine the radius of our angle is 69 degrees. Place your carpenter's 90-degree angle along the adjacent wall and slide it as close to the angle as possible. Note your dimensions and use the same formula and table of trigonomic ratios to find the radius. During a field measure, it is easy to become sidetracked and miss important elements. Stay focused. Save your qualifying for when your clients are in the showroom. Save your math calculations and design planning for when you are at the drawing board. The next wall is the obtuse angled wall, or a wall with an angle over 90 degrees. The radius of this type of angled wall is frequently assumed as always being 135 degrees. Unless the radius is documented on a blueprint, you should never assume the radius of any angled wall. We draw the shape of the room and fill in our dimensions. With the long side facing the angle you want to identify, place your carpenter's angle along one of the straight walls. Close off the gap with your second carpenter's angle and measure the perimeter. Using the same formula and table of trigonomic ratios, we can determine the angle in our perimeter is 60 degrees. We add the two sides for the total. The radius of our angled wall is 150 degrees.